All right, Dr. Scott D. Thank you for taking the time to talk to us today. For everyone's information, Dr. D is the research director at Pipestone Veterinarian Services. So, Scott, can you give me a brief explanation of why the trailer chest was chosen to evaluate atmosphere?
Yeah, hey, I really appreciate this opportunity to meet with everybody, and I appreciate the opportunity to talk about this trial. I really think it's a cool trial. I think it told us a lot of neat stuff. We learned a lot of new things, saw a great product in action under a very highly regimented scientific regime. So I'm excited to share it. And history-wise, back in about 2002, I started doing transport sanitation research. Some of you in the audience might remember that when I was at the University of Minnesota. And I looked at PRRS virus primarily, but I used models of trailers that were scale models. And we went through various sanitation protocols. And so it's an old way of approaching, the ability to test new products. And it just was a good opportunity when AG Forte came along. Let's put it through the same rigor, just as we have everything in the past since basically 2002. So it's a very strenuous test, and I'm very happy that we can talk about that today.
Yeah, absolutely. So what did we test for to determine atmosphere's effectiveness?
Yeah, we looked at three viruses, Seneca virus, PED virus, and PRRS virus, using a model of how contaminated transport trailers are cleaned in a swine system. So this picture here shows models. These are basically 1 to 75 scale of a 50-foot double deck transport trailer. So we scale everything down to meet to represent what's actually happening in the big trailer, but down in the model. So you can see these are aluminum boxes. They've got flanges, they've got brackets, they've got hard to clean areas. I really like using these to kind of represent the real thing, basically.
Okay. And can you explain the protocol and test model used?
Yeah, so if we go to the next slide, basically what we do is, it sounds real simple, and it is. We take a pound of feces, a pound of manure. We inject into that manure 20 milliliters of the virus. In this case, you can see it's PED that we're using here. So 20 milliliters, 4 sites per pound. You see kind of where we would insert the 5 mils. Then we mix the ball of feces with the 1/4 pound of shavings to kind of give it an organic feeling. And this is what we use to then go ahead, and if we move forward to the next slide, you can see how we spread the material basically by hand on the interior of these models to try to represent what a trailer's like after you've hauled a load of pigs to the harvest facility. You kind of see the biofilm there on the right. We let it dry for about an hour to get it real sticky and tacky, and just to try to simulate the real world. So it's an aggressive challenge. So yeah, that's kind of how we set it up, and then we start the clean process. So here you can see each trailer has its own little scraper. So we basically go through the process just like we would if we were the actual truck wash in a system. We physically remove the debris, and we use separate scrapers per trailers in this case to try to maintain integrity from experimental unit to unit. Mm-hmm. After that, we begin to apply the detergent to try to break down the biofilm. You kind of see how that goes. That's pretty straightforward. That stays on for about a 10-minute period of time, just like we would in our specific protocol in Pipestone. And the next slide shows you what follows after that is basically the power wash process. Now here's where we take some time to isolate the trailers. We've got 6 of these in a room, as you know, and we don't want splashed back and forth. So you can see as we're washing the individual trailer, we've got a bag on all the other trailers in that same room, so we're not getting cross-contamination while washing. So this is a process we do to kind of simulate, again, the power wash. Okay, so if we move next, we and then add the disinfectant, and we put it on based on a scale of a full-size 50-foot double-deck trailer. So in our system, it takes 15 minutes to disinfect that full-size unit. We scale that down, and we only apply disinfectant to the model for a 12-second period of time. You can kind of see, obviously you could sit there all day and spray these things and it would be very, it'd be artificial. So we only disinfect for a representative period of time. We don't want to over disinfect. We don't want to over saturate the surface. Obviously we'd get probably some false negatives, but so a 12-second period is all we apply the disinfectant, and we count that out for each trailer. We stop. Now, throughout the process, we're sampling the surfaces inside each trailer using the Swiffer approach. Probably familiar with that, the Swiffer pads that you use in your house. We found these to be very effective ways of looking for virus. And so here is a Swiffer pad in action, sampling the interior surface. The other comment I would make for any scientists in the room who have done this work, we also add a disinfectant neutralizing broth after collection. Now, this is an important step to really improve the results, because think about it. If you swabbed your trailer model after you disinfected, and that test tube sat in the lab overnight before it was tested, that disinfectant residue is probably going to run continually and possibly give you a false negative result. By adding this neutralizing broth post-collection, we stop the action of the disinfectant. There's not this continual exposure to disinfectant. So it basically allows us to say at 30 minutes or 60 minutes or 120 minutes, wherever we take that test, collect that sample, that's the point where the disinfectant was working and not beyond that. So that's a real important kind of subtle way to improve the scientific quality of your study. Okay. So I guess, Rebecca, here we're into some of the results. Any questions on the methods that you want to review, or are we moving in the right direction?
I believe that we're moving in the right direction. Can you just clarify? We were testing synergized barnstorm versus atmosphere and atmosphere, correct?
Good point. Thank you for asking that. Yes, we went in, synergized was part of this model. It's kind of like, everybody knows, the gold standard. We wanted to compare AG Forte to that gold standard. And so we used barnstorm synergize side by side with AG Forte at the dilutions you see on the slide. So we did want to compare it to the gold standard. We also had a positive control, as you can see on this slide, which basically was a trailer model that was contaminated but was not treated. It was not cleaned. We sampled it over time just to show that the virus was going to stay there. If you don't do something, the virus is it's not going to magically disappear on its own. It's going to be there.
Right.
Yes.
Okay, so can we go over the conclusions of the trailer disinfection test? And also, can you explain how Atmosphere AG Forte Pro did as a detergent phase?
Sure. So I think these next few slides, we'll just take them one by one. I think this really brings home the message that we want to deliver. We've done this 2 times now. The results were very impressive the first trial, and we said, well, we better do it again just for power. So remember, we had Seneca, that's SVA, PED, and PRRS virus in each of the trials. Let's go back, please, to the trial 1 with Seneca. So on the left-hand column, you see AG 1 to 128, AG 1 to 256. That's the AG Forte product at a 1 to 128 dilution or a 1 to 256 dilution. There's a synergized product at 1 to 128. That's the concentration we utilize in Pipestone. There's our positive control. Now, what we're looking at here is, we call it VI, so virus isolation. So is the virus alive or dead? That's what we want to measure here. What's the effect of the AG Forte on killing the virus? Same with, and how does it compare to synergize? And what if you don't do anything? Does the virus still live in the environment? And you can see here, at the top, we've got the time periods where we sampled. So 0 minutes post disinfection, 30 minutes post disinfection, 60 minutes post disinfection, et cetera, et cetera. And so 0 minutes, everything's positive, like you'd think. And then you can start to see the differences in how the products compare to the positive control. So at 30 minutes, in both dilutions of atmosphere or AG Forte, we had negative results, as we did with Synergize, and that those results were repeated throughout the 240 minutes. Notice in the positive control, if you don't do something, the virus hangs around. This is a very sturdy virus. It's a non-enveloped virus. It's a very stable virus outside the host. So those were the results for Seneca, which I thought were pretty amazing. And I think if we scroll through the rest of the slides, we've got here's the PRRS, and you kind of see the same setup on the slide. So you got your products on the left and your time on the top, and you kind of see the results. And those results are the same. Really no difference. Here's PED, no difference. Everything's negative, except for the positive control. All right. So those are good results. We wanted to do it again. And so I think the next slide might talk a little bit about, here's the Seneca work. Same setup, we just had a little different, we did some more replications. You see we've got AG Forte at two replicates at 1 to 128, 2 replicates at 1 to 256, Synergize again at 128 in positive control. There's virus isolation for Seneca at 0, virus isolation at 60, 120 and 240. And basically you see the same thing as we saw before. Both products performing equally across this very stable virus. Follow that up with the work on the next slide on PRRS. Same result, everything staying negative throughout the testing period across products. And the next slide will show you the PED. So very similar data to what we saw in trial 1, which gives us great confidence that the repeatability of this product is very good. Mm-hmm. So kind of if we go to the final conclusion slide, basically how we took it home was both products performed equally across all 3 viruses. My experiences when I was working with the AG Forte product, it was much less irritating, and it took a lot less time to clean the surfaces of the trailer models than it did with the Barnstorm. It was amazing how quickly the atmosphere, the AG Forte product cut through the biofilm. And so the time it took me to wash these, well, I didn't measure it, but I just by experience, it took a lot less time. That was nice. So it was easier to work with, and it took less time. But it worked well at both concentrations, and you can see the positive control. If we don't do something, the virus is not going to go away. It's going to stay there the whole time. So we really have to intervene. We really have to treat with appropriate products to sanitize those surfaces. So that's it. Those are the tests we did on the trailer sanitation model, Rebecca.
Great. Well, I appreciate you talking to us about the trailer sanitation test that we performed with you. And I'd like to go into the sow barn research that you guys performed at Pipestone. Can I ask you, who at Pipestone did the sow barn research?
Yeah, this was some really nice work that was done by Dr. Emily McDowell and Dr. Luke Minion. I think many of you in the audience know Luke. Dr. McDowell kind of ran the project, boots on the ground, so to speak. She did a great job. So it's a very interesting project looking at how this product would perform in an actual farrowing room.
Right. So why was there interest in this research project?
Well, we were looking at a couple things. We're looking at wash time. Can we shorten that? Water use, can we shorten that? Personnel safety, can we improve that? Those are good points when we're looking at a new product. Mm-hmm. Does it have those benefits? And by the way, does it also maintain good piglet health in the farrowing house? So there was also, besides those measurements, there was measurements of diarrhea and piglet health along the way too.
Okay. What were the details of the study?
Well, there were rooms that were basically sanitized with either AG Forte or Synergize through the normal process. So AG Forte, cleaning, disinfecting, Synergize, Barnstorm. and then Synergize. And basically, people just measured things. They measured how long does it take me to wash this room, clean it up, how much water am I going to use, and then what's the effect on the piglets? Do I see a higher level of scours in certain groups or not? So it was a really straightforward, simple trial, but it was cool because it was done on a 5,400 sow farm. So there's the real world involved here.
Wow, that's incredible. What were the findings that Dr. McDowell and Luke Minion made?
Yeah, really neat. Much shorter wash time, much less irritation to people. So the personnel really liked working with it because it took less to clean the room, but it also made them feel better when they were in the environment working with it. And then there was no difference in piglet performance, diarrhea scores, mortality, etc., from product to product. So the rooms got cleaned faster, less water was used, people were happier, and the piglets were fine. There was no change in piglet performance. So that was a really cool study. I'm glad they did that.
Mm-hmm. What has the use of atmosphere done for the sow farm operation?
Well, as we move the product into farms, we're seeing and hearing some really good things. It's getting well adapted on site. People are basically reporting similar outcomes as the trial showed them. That's easier to work with. Again, no change in piglet performance or piglet health. And it's just, I think we're being better environmental stewards because we're using less water. So there's a lot of good things, a lot of good feedback so far.
Yeah, it sounds like it. So where else do you see atmosphere being used in hog farm operations?
You know, that's a good question. I'm very confident in its ability to kill pathogens. I'm very confident in its ability to help us improve the cleaning process, and I'm very convinced it's going to be better for our staff. So what I'm wondering about is what else could it do? What could it do for odor control, perhaps? Could it reduce odor?
Yeah, I mean, we'd like to find out too.
Yeah.
Can AG Forte Pro be used in low temperatures?
I think that's a good question. I think all disinfectants are sensitive to temperature. We know that if the temperature gets really, really cold and things start to freeze, disinfectants don't work as well. So in the past, we've utilized mixing the disinfectant with windshield washer fluid or a 10% propylene glycol, and that keeps the product from it keeps the product from freezing and keeps it in a liquid form. So yeah, I'm sure if we modify the delivery, we can use AG Forte in cold weather just like we can anything else. It's not so much the product, it's how we keep it in a liquid state.
Absolutely. What is Pipestone's perception about the eco-friendly component of atmosphere?
We like it. I mean, we're trying to do what we can for the environment. We're trying to do what we can for our people. We think it's safer. We think it's less irritating. And obviously, if we can reduce water use, that's good for everybody. So we like that approach as well.
Yeah, absolutely. So you've gone over a lot of great points about atmosphere and its benefit towards the environment, reducing water, being better for your employees. Is there any other points that you would like to make about atmosphere as a product, and what would they be?
Probably the thing that really caught my attention with this, working with it was, I think people in the room know I introduced Synergize basically to the swine industry back in 2004 with its effectiveness against PRRS virus. I've never seen any other product, and I've tested a whole lot of them, that perform as well as Synergize against viruses. This is the first product I've seen in basically 14 years that has equal efficacy in regards to viral decontamination. So I'm a microbiologist, I'm a virus person, so those kind of things really catch my attention.
Well, great. Well, I really appreciate you taking the time to explain the trailer test and the sow barn research that Pipestone conducted, and explaining a little bit more about atmosphere and what your findings were and what your feedback of it has been.
My pleasure. I'm excited about the future working with this new product, a new solution to an old problem.